I decided to use a slide to present my stuff. My first one is precipitation. How is it formed? So most of the time it comes from clouds, obviously. The water droplets form inside of the cloud from the water vapor. The water molecules and water vapor that form the water droplets start developing. They attach to particles like sea salt, dust, ice, and even pollution that's already in the atmosphere. And this is the start or beginning of the precipitation forming. Once the cloud is full, those small droplets that keep combining to make the bigger ones, once they're too heavy, they fall, and that is precipitation. I have rain, snow, sleet, and hail. First, we'll do rain. So, according to our textbook, I pulled this definition. Restricted drops of water that fall from a cloud and have a diameter of at least 0.5 millimeters. That is what rain is. And most of our rain comes from nimbostratus clouds, or the more popular known rain cloud, the cumulonimbus, which is like the storm cloud. Snow. The definition of snow is precipitation in the form of ice crystals or snowflakes, or more often aggregates of crystals. The size, shape, and concentration of the snowflakes depend to the great extent on the temperature when they form. Sleet, according to the textbook, again, a wintertime phenomenon and refers to the fall of small particles of ice that are clear to translucent. For sleet to be produced, a layer of air with temperatures above freezing must overlie or be on top of a sub-freezing layer near the ground. Hail is precipitation in the form of hard, round pellets or irregular lumps of ice. Moreover, large hailstones often consist of a series of nearly concentric shells, differing densities and degrees of opaqueness. I got my pictures from Google. These are my links at the bottom. Let me see. I need to move this so I can. Okay, the next one is the 4 types of fronts. We have warm fronts, cold fronts, then our stationary and occluded. A warm front is when the surface position of a front moves so that the warm air occupies territory formerly covered by cooler air. I put a picture on here. I was kind of confused at first when I was trying to find them and how to understand these ones compared to the ones in the textbook, but eventually I got it. A cold front is when dense cold air is actively advancing into a region occupied by warmer air. Then we have our stationary. The flow on both sides of a front is neither toward the cold mass nor towards the warm air mass, but almost parallel to the line of the front. The surface position of the front does not move. As you can see right here in the middle, they kind of meet. Our occluded is an active cold front that overtakes the warm front. As the advancing cold air wedges the warm front upward, a new front emerges between the advancing cold air and the air over which the warm front is gliding. Right in here, it sees that it's pushing away the cold, and over here too, where the warm is. Our next one is lifting of air. On this one, we have orographic and convergent. Oh my gosh, it's taking forever to load. The orographic lifting happens when there's a mountain or another type of elevated landform which poses as a wall or a barrier. The flow of arrows traveling up one side of the mountain, I drew a picture. There's vegetation on one side of it, and that's because the precipitation is only on the windward side. This is the side that's getting the precipitation in order for the vegetation to grow. But on the other side of the mountain, there is no rain or vegetation. And this is because once the air crosses over the mountain, the moisture is now gone. It's no longer there, which means obviously no precipitation or rain for the leeward side, meaning that there's not going to be any vegetation or anything. Next is the convergent lifting. When air is flowing in from different directions, Right here is where I put my arrows for the air coming in. That air's and it's going into itself and it's got to go somewhere, so it goes up. The air is not able to go down, and this is what will take us into the adiabatic cooling. And this I seen in the textbook that there's also a chance of a cloud forming from all of this. Convergence can also happen when air is coming from different surfaces, so it will not be staying consistent. The airspeed will actually slow down. This means that the air is just going to keep stacking on top of itself. So instead of just staying there, it starts to rise up.